How did the universe come into existence? How our solar system was formed? How were our planets created? How did the terrifying celestial bodies like black holes were formed? These questions have intrigued us since childhood, and even now as adults, we are always searching for answers. Throughout the history of humankind, numerous scientists have their explanations in the quest to explain the complexity of the cosmos. Albert Einstein was a world-renowned theoretical physicist and the father of the general theory of relativity, a discovery that became the turning point in our understanding of the cosmos during the early 20th century. The theory described the structure of space and time, proving that the universe isn't something that stays static or constant, but rather expands at a rapid pace. Since the release of Einstein's theory, scientists have made groundbreaking discoveries and formed numerous other explanations which tried to explain the birth of our universe. Among these theories, the Big Bang was widely accepted. Why's that? Well, let's find out. Big Bang creation of the universe. Before the theory of the Big Bang, the astronomer Georges Lemaitre explained in 1927 that the entire universe was initially just a single point. That single point later expanded into what we now call a universe, which is even to this day still expanding to unknown lengths. 2 years after his explanation, Edwin Hubble discovered that the galaxies also move away from us. He also discovered Hubble's law, which states that speeds are proportional to their distance and occur in all directions. His discovery once again proved Einstein's theory of relativity that the universe was and is still experiencing an ongoing expansion. While all the scientists were racing to solve the unsolvable riddle of the creation of the cosmos, a person came up with a startling idea. His name was Georges Lemaitre, a cosmologist and a Catholic priest. He gathered the knowledge of all the previous theories regarding the expansion of the universe, and in 1931 he presented the idea of singularity. The idea presented a possible explanation, which stated that the universe was born from an unimaginably hot and dense point which existed more than 13 billion years ago. The point contained, or more appropriately, compressed all matter, energy, space, and time, which later exploded, but not in space. Rather, the space itself expanded from that singular point. Everything that existed to this day was all inside a point that was so small that even now we can't figure out its size, so we can just call it zero for now. Georges Lemaitre named his theory of the beginning of everything the Big Bang. So that was the brief story of the Big Bang theory, but there's still much more to discuss, such as what happened before, during, and after the explosion that gave birth to life itself. The Big Bang event. We already know that the Big Bang event all started from the point of singularity, but what happened during the exact moments when the particle exploded and the universe rapidly started to expand? Well, let's find out. The inflationary epoch. Before we start, we need to clear the misconception regarding the Big Bang, which is that the entire universe was created due to a massive explosion. But no, that wasn't an explosion. It was all just space which stretched everywhere into nothingness. There was nothing outside the universe, and the universe expanded into itself. It's a bit confusing, but that's just how it is. The space stretches towards nothingness because there are no borders or anything like a vessel, it's just purely nothing. The quark era. Right after the inflationary epoch, the universe reached the early moments, which scientists named the quark era. During these moments, the universe was unimaginably hot, with temperatures exceeding billions and trillions of degrees Kelvin. The entire universe was like a boiling bowl of soup, packed with incredibly high energy. The strong nuclear forces unified into a single force, creating quarks, also known as the elementary particles that make protons and neutrons. Quarks roamed freely during the early stages of the expansion and were known as quark-gluon plasma. But the phase didn't last long, and the particles combined and formed hadrons. The lepton and hadron era, the quark era, was then succeeded by the lepton and hadron era, in which the universe started to cool down as it expanded further into nothingness. The universe's cooling was an essential phase for the formation of much more stable particles to exist. Leptons are subatomic particles that have very low mass with low nuclear forces. Electrons and neutrinos are the two of the primary leptons that formed during this era. On the other hand, hadrons, such as protons and neutrons, contained strong nuclear forces. As the universe was cooling down, more and more leptons and hadrons formed, which resulted in the formation of stable nuclei. The nucleosynthesis era. The nucleosynthesis era begins a phase in which essential elements like hydrogen and helium are formed through processes like proton-proton chain and helium fusion. Everything occurs primarily in the cores of stars, forming the universe's elemental composition. The forming of light elements like hydrogen and helium laid the foundation for heavier reactions of elements within stars and supernova explosions, resulting in the birth of even more stars across the universe. The opaque era. During the opaque era, the universe, while still being incredibly hot and dense, was a plasma of charged particles. Due to the scattering and absorption of photons by the charged particles in the hot plasma, the entire universe was opaque to the high electromagnetic radiation. As the universe went cooler and cooler, it started to transition towards transparency, which resulted in the release of cosmic microwave background radiation. The CMB radiation is a faint glow of the microwave radiation spread all across the universe and represents an afterglow of the events of the Big Bang itself. These radiations were never visible to the naked eye, but thanks to our technology, we can now detect these faint glows, allowing us to glimpse the aftermath of the explosion that created the universe. Birth of stars and galaxies. When the universe gradually cooled down, which took billions of years, the particles that contained high energy from the early eras started to lose their thermal energy. Gas clouds started forming, mainly composed of helium and hydrogen, and these clouds would later become the birthplaces of billions of stars. Within these clouds, gravitational instability started to emerge, and matter began to clump together due to their difference in densities. The densest regions of the gas clouds collapsed, resulting in the initial formation of the cores of stars, and nuclear fusion reactions began within these cores, marking the birth of future stars. Galaxies started to form rapidly thanks to the gravitational attraction between stars and gases in the universe. Among the billions of galaxies, our Milky Way galaxy also came into existence. We live in only a fraction of it, called the solar system. It's said that the universe is approximately 93 billion light-years in diameter, an immense size that took over 13.8 billion years to form, and it's still expanding further and further into the void. We humans can only observe the limited area of the universe, which is not even the 0.1 fraction of our galaxy. There's a lot left to explore. Amazingly, we've not even completely explored our galaxy yet. There are still billions of other galaxies like Andromeda, Pinwheel, and many more, like the Triangulum galaxy, left for us to explore. Before the Big Bang. You must have noticed that we didn't start the video from the time before the Big Bang ever occurred. That's because we don't know what existed before the massive explosion. Some scientists say the time that bounds us is itself a creation after the Big Bang. So, discussing something like that is nearly impossible for a being created after the explosion. Some theories even suggest the idea of a multiverse, which states that our universe is a part of another massive thing which contains several other universes, just like how several galaxies exist in one universe. Some go as far as quantum cosmology and try to understand the concept of the universe through quantum physics. We still couldn't figure out several other mysteries within the universe, such as dark matter and dark energy. Well, that's a topic for another video, so that was the end of today's journey through the beginning of the universe, the Big Bang. It is a complex topic that's still a mystery after all. A theory remains a theory until it becomes a fact, but for now, it's only a theory that definitely contains several flaws. But all the talk comes to the same question: what started it all? What created the point of singularity? The answer is, we don't know, or maybe we'll never know. Hope y'all enjoyed today's video. If you did, hit that like and subscribe button, and we'll see you guys next time. Until then, bye.